Welcome to Olympiad Primer. Do you want to learn any mathematics beyond your syllabus? Do you want to sit for any mathematical Olympiad exam? Then you are watching correct channel. Today in this video, I will teach you a mathematical trick on number theory which will enable you to solve a challenging problem. In this video, we will discuss two challenging problems that were asked in Indian Mathematical Olympiad, the Regional Mathematical Olympiad in the year 1990. You should focus the mathematical trick. The problems are on divisibility and remainder. The topic is very much important because it is common in mathematical Olympiad exam. Any one question at least will be on this topic, so it is very much important topic. I think you all will enjoy and will feel thrilled to solve this problem. Okay, so let us come to the problem. The first problem was a very challenging one, and the problem was asked in Indian Mathematical Olympiad, the Regional Mathematical Olympiad in the year 1990. The problem was on divisibility and remainder. N is a 50-digit number in base 10. All digits except the 26th reading from the left are 1. Given that n is divisible by 13, find the 26th digit. This is the problem. Before approaching to solve this problem, we have to warm up. We have to learn some technical trick. Here the number is a 50-digit number. All are ones except 26th from the left, that is before the unknown number. Suppose the unknown number is x, so before the unknown number there are 25 ones, and after the unknown number there are 24 ones. So this is the number, and it is given that the number is divisible by 13, and we have to find out the value of x. So well, just we have to warm up. And how test of divisibility works, we have to know how test of divisibility works. Suppose we have to find out the criteria for a number being divisible by 30. Being divisible by 3. Suppose n is a number, 11-digit number like A, B, C, D, E, F, G, H, I, J, K, and the number is divisible by 3. We have to find out the criteria, and the number n can be expressed in this form of the summation of power of 10 and multiplied with the digit like this: k plus j into 10 plus I into 10 square plus h into 10 cube plus g into 10 to the 4. All this like this, and we have to find out the remainder when n is divided by 3. And now the remainder of various power of 10 when divided by 3. Just we have to find out the remainder, power of 10 and remainder when divided by 3. 10 to the power 0 means 1, so 1 will give 1 as the remainder when divided by 3, and 10 will give the also remainder 1, because 3 3s are 9, and from 10 minus 9 will give 1, so 10 will give the remainder 1 when divided by 3. So when 10 square, the remainder is 1. When 10 cube, the remainder is 1, because if 10 gives the remainder 1, so 10 square gives the remainder 1 square. And also if we think 100, and 100 if we divide 100 by 3, then 33s are 99, and there also we get 1 as the remainder. So 10 square will give the remainder 1. So in this way 1000 will give the remainder 1 when divided by 3. And also we will think that if 10 gives the remainder 1, then 10 square will give the remainder 1 square, that is 1, and 10 cube will give the remainder 1 cube, that is 1. So in this way all power of 10 will give the remainder same as 1, and in this way we will find the remainder value of the number n in this way: k into 1 plus j into 1 plus I into 1, etc., etc. So in this way, and therefore the remainder of n when divided by 3 will be k plus I plus j plus k plus j plus I plus h plus g plus a plus e plus d plus c plus b plus a. That is nothing but the sum of the digit. So in congruent we can write incongruent sum of the digit modulo 3. That is, if a number n is divisible by 3, then the sum of its digits will be divisible by 3. So it is the condition of test of divisibility by 3. Very nice. And now suppose we can go for the divisibility by 9. Number is the same, 11 digit number, and the number can be expressed in the form of the sum of power of 10 and multiplied with its digits respectively in this way. And we have to find out the remainder n when divided by n. So in a table we can write this like this: 10 to the power 0, that means 1 itself will give as the remainder when divided by 9, and when 10 divided by 9 will give also the remainder 1. So in the same way 10 square will give the remainder 1 square, that is 1, and then equally 10 cube and all the power of 10 will give the remainder always 1. So in this way the remainder value of n will be like, by putting the remainder value of power of 10, we will get the remainder value of n like this, and the remainder value of n will be nothing but the sum of the digits, like the divisibility of 3. So in congruent also we may write incongruent digit sum of the digit modulo 9. That is, if a number n is divisible by 9, then sum of its digits will be divisible by 9, because the remainder is here the sum of the digits. So since the number is divisible by 9, so its remainder will also be divisible by 9. Now we may go for the divisibility test for 11. In the same way, the number is the same. Suppose a, b, c, d, e, f, g, h, i, j, k, the 11 digit number, and the number is divisible by 11. Then n can be expressed in the form of summation of 10 multiplied with its digit like this, and we have to find out the remainder when the number will be divided by 11. And also in congruent we can write like this: 10 congruent minus 1 module 11. Here you see remainder as -1, because when 10 will be divided by 11, then actually 10 will be the remainder, and we can also write the remainder 10 as -1. So when 10 will be divided by 11, the remainder will be -1. We can take -1 as the remainder. So 10 congruent -1 modulo 11, and 10 square will give the remainder -1 square, that is 1 modulo 11. So the remainder of various power of 10, we can write it like this: 10 to the power 0 means 1, so 1 will give the same as the remainder when divided by 11, and 10 will give the remainder minus 1, either 10 or minus 1, and here we will write minus 1 as the remainder, and it has the great advantage also, because all power of 10 will get the value of remainder in a very simple way, that is the power of minus 1, that is 10 to the power 1 is minus 1, and 10 to the power 2 will give the remainder minus 1 to the power 2, that is 1, and 10 to the power 3 will give the remainder minus 1 to the power 3, that is minus 1, and 10 to the power 4 will give the remainder minus 1 to the power 4, that is 1. So the even power always will give plus 1, and odd power will give minus 1 as the remainder. So the remainder value of n will be like this. By putting the remainder value of all power of 10, we can have the remainder value of n like k into 1 plus j into minus 1 plus I into 1 plus h into minus 1 plus dot dot b minus 1 plus a into 1, and so remainder value of n when divided by 11 will be equal this. So like this, and now the divisibility of 11 will be like this. Now see, the remainder value of the number when divided by 11 will be the alternate sum of the digits at 1 plus 1 minus from the right side, that is k minus j plus I minus h plus g minus f plus e minus d plus c minus b plus a. So when a number is divisible by 11, then from the right side of the number, every digit, the sum of every digit, actually the alternate sum of every digit from the right side will be its remainder, that is also divisible by 11. That is, if a number n is divisible by 11, then its alternate digit sum will be divisible by 11. So it is the condition of test of divisibility by 11. So it is very nice. Now we can go for the test of divisibility by 11 by expressing the congruent arithmetic. And now we can go for the divisibility test of 99. For 99, when a number will be divisible by 99, that is 1 less than 100, then what will happen? Then see, 99 is 1 less than 100, so conveniently digits of n be written as 2-digit block from the right side. Suppose number is the same, a b c d f g h I j k, but you have to block 2-digit from the right side. First kj, then second block ih, then third block gf. So in this way, ed, then cb, and then only a. So then the number can be expressed in the form of various power of 100 multiplied with these 2 digits from the right side, like first jk into 100 to the power 0, that is jk only 1, jk into 1, that is jk, and plus hi into the second block hi into 100 to the power 1, so hi into 1, plus next block, that is fg into 100 square, plus next de 2-digit block d into 100 cube. So in this way, plus bc into 100 to the power 4. Next, now the remainder of various power of 100 when divided by 99 or 11, because 11 is the is a factor of 99. So we can write also the number is also divisible by 11. Now 90, we can consider only 99 divisible by 99. So power of 100 and remainder. When 100 to the power 0 will give 1 as the remainder, because 100 to the power 0 is 1. So 1 itself as the remainder when divided by 99. And when 100 will be divided by 99, then 1 will be remainder. So 100 to the power 1 will give the remainder 1, and 100 to the power 2 will give the remainder 1 to the power 2, that is 1. So in this way, all power of 100 will give the remainder 1, always 1. So remainder division, the remainder of n division 11, that means when the number n will be divided by 11, then the remainder will be congruent jk into 1. By putting the remainder value of various power of 100, we will get the remainder like this: jk into 1, hi into 1, fg into 1, d into 1, bc into 1 plus a. So remainder of n division 11 equal to jk plus hi plus fg plus de plus bc plus a. So like this, and then remainder value will be the sum of two digits from the right side. That is why in congruent also we may write n congruent, the sum of 2 digit modulo 11. That is, if a number n is divisible by 11, then its 2 digit sum will be divisible by 11, and it can be taken as the test of divisibility by 11 as well as 9 or 99. And then, what is the secret of such an interesting device of test of divisibility? When any divisor or its multiple being 1 less or 1 greater than 10 or 100 or 1000 or 10,000, then we can get this interesting result, this interesting criteria for divisibility. Suppose the divisor is 9, 1 less than 10. Then in congruent arithmetic, we can write like this: 10 equal to 1 plus 9, and 10 congruent to 1 modulo 9, and 10 square congruent 1 square, that is 1, and 10 cube gives 1 cube, that is 1. So in this way, the remainder value of the number n can be computed like this, and we have got the decision, the sum of the digit sum, the sum of its digit, that will be the remainder, and therefore the decision is the digit sum would be divisible by 9. And when the divisor is 11, that is 1 greater than 10, then we can write 10 equal to minus 1 plus 11, and in congruent arithmetic we can write 10 congruent minus 1 mod 11, and also 10 square congruent minus 1 square, that is 1, and 10 cube congruent minus 1 cube, that is minus 1. So in this way, the even power of 10 will give only positive 1, and odd power of 10 will give minus 1 as the remainder. So in this way, we have got the remainder value of the number n by putting the value of various power of the 10 in the number expressed in the form of summation of power of 10 multiplied with digit. We will get the remainder value k plus j into 10 plus I into 10 square plus h into 10 cube plus total plus a into 10 to the power 10, and when we put the value of the remainder value of the various power of 10, then we will get k minus j plus I minus. So in this way, we can get the alternate digit sum. it is called the alternate digit sum, plus minus from the right side. Then the remainder value in k minus j plus I minus h plus g minus h plus minus from the right side. The digit will be plus minus, and it is called the alternate digit sum. Yes, the alternating digit sum from unit digit would be divisible by 11. And when now we can consider 99 as the divisor. When a number is divisible by 99, that is 1 less than 100, then what will happen? So in the same way, we can find it. 100, we can write 100 equal to 1 plus 99, and therefore 100 congruent 1 modulo 99. That is, when 100 will be divided by 99, then 1 will be its remainder, and that is why it is written like this: 100 congruent 1 modulo 99, and then 100 square, that is 1 square, that is 1, and 100 cube, that is 1 cube, that is 1. So always all power of 100 will give 1, always 1 as the remainder. So the remainder of the total summation of the expression value of n, the remainder of n will be congruent the sum of its 2-digit block from the right side, that is jk plus hi plus fg plus de plus bc plus a, and the division will be the 2-digit sum from unit digit is divisible by 99, and since 9 and 11 are its two factors other than 99, so also the same criteria will be worked when in case of 9 and 11. And next we consider for the divisor of 101, that is 1 greater than 100. When a number is divisible by 101, then what will be the remainder? Suppose a number is divisible by 101, then what will happen? We can write 100 equal to minus 1 plus 101, and therefore when 100 is divided by 101, then actually 100 will be the remainder, but we can write minus 1 as the remainder, and that is why in congruent arithmetic we can write like this: 100 congruent minus 1 modulo 101, and then 100 square congruent minus 1 square, that is 1, and 100 cube congruent minus 1 whole cube, that is minus 1. So even power will give positive 1 and odd power will give minus 1 as the remainder and divided by 101. So clearly the remainder value of the number n will be like this. Here the number n can be expressed in the form of 2-digit block from the right side, and in this way, by putting the value of the remainder value of 100 and 100 square and 100 cube respectively, we can get the remainder value of the number n like this: jk minus hi plus fg minus de plus bc minus a, and therefore we have got this alternate digit sum. Yes, alternate digit sum. Therefore we come to the decision: the alternate 2-digit sum from unit digit is divisible by 101. Next we can consider the divisibility for 999. It is 1 less than 1000. So here we have to express the number in the form of 3-digit sum, 3-digit block from the right side, and the number will be expressed in the form of 1000 various power of 1000, summation of various power of 1000 we multiplied with the 3-digit block from the right side. Again, see, 999 has 6 other divisors: 3, 9, 27, 37, 111 and 333, other than 1 and 999. So if a number is divisible by 999, that means the number is also divisible by any number of these 3, 9, 27, 37, 111 and 333. Now, in congruent computation, we can write 1000 equal to 1 plus 999, and in congruent arithmetic it can be written like this: 1000 equal 1000 congruent 1 mod 999. That means if the number 1000 is divided by 999, then 1 will be the remainder, and it can be expressed in this way, that is 1000 congruent 1 mod 999, and then 1000 square congruent 1 square, that is 1 mod 999, and in this way 1000 cube, that is also 1 cube, that is 1 mod 999. So in this way all power of 1000 will give the remainder 1, and by putting this to the number expressed in the form of summation of 1000 multiplied with 3 digits, this we can get the number here A, B, C, D, E, F, G, H, I, J, K, and we have to block 3 digits from the right side. We have to make a block containing 3 digits from the right side. First K, J, I, then H, G, F, then E, D, C, and then A, B. So the number can be expressed then in this way, that is the summation of various power of 1000 multiplied with 3 digits like this: I, J, K, the last 3 digits, into 1000 to the power 0, that means 1, that is only I, J, K, plus F, G, H, the next block of 3 digits, F, G, H into 1000, plus C, D, E into 1000 square, plus A, B into 1000 cube. So, and by putting the value of various power of 1000, the remainder value of 1000 various power of 1000, we get the total sum like this: ijk plus fgh plus cde plus ab. So the remainder of n when divided by 999 will be congruent ijk plus fgh plus cde plus ab. And so we have come to the decision that the 3-digit sum from unit digit is the remainder, and since the number is divisible by 999, so the 3-digit sum will be divisible by 999, and also also by any one of its factors, that is 3, 9, 27, 37, 111 and 333. Next, we consider the 1001 as the divisibility. By the divisibility of 1001, if a number is divisible by 1001, then what will happen? 1001 is 1 greater than 1000. So the test of divisibility will be like the same way. Here 1001 is also equal to 7 into 13 into 11. So if a number is divisible by 1001, that means the number is also divisible by all its factors, that is 7, 13, 11 or 77, 91, 143, because 1001 has other divisors. These are the other divisors than 1 and itself. Now we can write 1000 equal to -1 plus 1001, and in congruent arithmetic we can write 1000 congruent -1 mod 1001. So 1000 gives -1 as the remainder when it is divided by 1001. So 1000 square congruent -1 square, that is 1, and 1000 cube, that is -1 cube, that is 1, -1 as the remainder. So every positive power gives only positive 1, and every even power will gives 1 positive 1, and every odd power of 1000 will give -1 as the remainder. And so we can easily calculate the remainder of the n like this, because the n is equal to I j k plus f g h into 1000 plus c d e into 1000 square plus ab into 1000 cube. And the number can be expressed in the form of 1000 summation of power of 1000 multiplied with 3 digit from the right side, 3 digit block, in this way. And by putting the value of the remainder value of the various power of 1000, we can easily calculate the sum like this. Here every even power of 1000 gives positive 1, and odd power of 1000 gives negative 1, and therefore we will get the alternate plus minus sum of 3 digit from the right side. The remainder of n when divided by 1001 or any one of its factors. Here 13 is also a factor, so we have taken here 13. So the remainder of n when divided by also 13 or 1001, then the remainder will be alternate 3 digit sum plus minus. Then come to the decision. The alternate 3 digit sum from unit digit is also divisible by 1001 or any one of 7, 13, 11, 77, 91 or 143. So it is clear. Now it is very important decision that if a number is divisible by 1001, then the alternate 3 digit sum from unit digit is divisible by 1001 or 7 or 13 or 11 or 77 or 91 or 143. Next we can approach the today's challenging problem. The problem: there are 50 digits number and one number unknown number is there up to 25, that is 26th number is unknown. We have to find out the value of the 26th number. So before 26th number there are 25 ones, and after that unknown number there are 24 ones, like this. And since the number n is divisible by 13, so the number must be divisible by 1001, because 13 is also a factor of 1001, because we know 13 into 7 into 11 equal to 1001. So 13 is a factor and 1001 is a multiple of 13. So since the number is divisible by 1001, so it must be divisible by 13 clearly. And now we can write 1000 equal to -1 plus 1001. We have previously seen it in this way, and in congruent it can be written as 1000 congruent -1 mod 1001, 1000 square congruent -1 square, that is 1, and 1000 cube congruent -1 cube. So positive power of 1000 will give +1, even power, sorry, positive, not positive power, even power of 1000 will give +1, and odd power of 1000 will give -1, that is -1, as the remainder when divided by 1001. So clearly we can compute the remainder value of the number when the number is 50 ones, and if the number will be A, B, C, D, E, F, G, H, I, J, K as our example, then it will be like the 3-digit alternate sum. We have seen it. So here like this, from the right side, that is 3 ones, 3-digit 1, and then again -3 ones, then +3 ones, then -3 ones. If every 3 ones are a block, 3-digit block, because the alternate 3-digit sum from unit digit is divisible by 1001, and here the number is divisible by, since the number is divisible by 13, so we can consider that the number is also divisible by 1001, and therefore the alternate 3-digit sum from the right side, that is, we have to block the 3-digit from the right side, and then every 3-digit from the right side will be alternately be plus and minus, plus and minus. That will be the remainder. So here the number is like this. So from the right side, if we write, and if we make 3-digit 31 as the first block, then we can write this, then the red, the blue colored one. So we have the first block, 3 ones are in blue, and then the next block 3 ones in red, then again 3 1, the third block in blue, and again the fourth block. So in this way, one alternate blue and red blocks we have here. So in this way, if we number the blocks from serially, we can write this like this, and we can see that after 8 blocks, that is after 24 ones from the right side, the unknown number, that is suppose x, will be in the 9th block, and then 10th block, that is 10th, and then 11th block. So we have made only 3-digit, the 3 ones from the right side, and serially it can go like this, and from 10th to 16th blocks, that is 16 into 3, that means 3 16s are 48, so 48 ones are written, and till remaining 2 ones will be there, because 16 blocks equal to 48 digits. So there are 2 ones will be in blue color, because here we see the odd numbered blocks are in blue color, and even numbered blocks are in red color. So here after 16th it will be blue. Now we have to compute the sum, because we know that since the number is divisible by 1001, because actually it is given that the number is divisible by 13, but we can consider it that the number is divisible by 1001, because if the number is divisible by 1001, then in this then its alternate 3-digit sum will be its remainder, and alternate 3-digit sum will be divisible by 13. So now we can compute the alternate 3-digit sum. So here every blue color one from the starting one block will be positive, one will be positive, will take its sign as positive, and the red colored blocks will take as minus 111, minus will take sign minus like this, because the alternate 3-digit sum. So first 1 to 8 blocks alternate sum will be like this, first block, then second block, then third block, so etc. up to 8th block, and that will they will take their sign like this, because blue colored block will take positive sign plus, and red colored block will take negative sign, and clearly the equal number of block blue color block and equal number of red color block, that will equal number of plus and minus 111, and that will give the result 0. And from 9th and 10th blocks, so 9 blocks and 10th blocks, so 9th block, that is odd number blocks, will take positive sign, and even numbered block will take negative sign. So this, and next 11th to 16th blocks, so 11th block like this, and it will take sign plus, and then 16th block up to 11th to 16th blocks, and therefore 16th block, that is positive numbered block, red color will take sign minus, and blue colored block will take sign plus. So clearly it will give 0, because here are also the equal number of green block and red block, so it will give 0. And then leftmost 2 digits, that is green colored 1 1 11. So now we can compute the total sum. First 1 to 8 blocks, 1 to 8 blocks, that is 0, and then 9th to 10th, 9 and 10th blocks, that is plus 1 1x, and then minus 1 1, that is 10th block, that is red color, that is minus 111, and then next 11th to 16th blocks, that is 0, and then the leftmost 2 digits, that is 11. So we have the total sum of the remainder of n like this. Here 11x is a 3-digit number, and its unit digit is x, and 10th digit is 1, and 100th digit is 1. So the value of 11x will be x plus 10 plus 100, that is plus 100 plus 10 plus x, and then minus 111, and then plus 11. So it will give the result x plus 10, but the remainder is clearly, the number is divisible by 13, it is given. So the remainder will be either 0 or 13. So here the remainder is x plus 10. So clearly it indicates that the value of x will be 3. Isn't it? The value of x will be 3. So it is the answer. So the full solution of this challenging problem is like this. Now we can go for another challenging problem. There are 1001 times 7 in number, like 1001 times 7, 1001 times, and if this number is divided by 1001, then what will be remainder? This is the problem. It is another challenging problem and the same category of divisibility. Suppose the number is 7n. So n is exactly 1001 times, isn't it? And here if this number n, that is 1001 times n, is divided by 1001 and it gives the remainder r, so at that time 7r will be the remainder of the given question, that is 7777. That is 7r will be the remainder of 7n. So 7r will be the answer. So now just we can find out the remainder for 1000 times 1. So suppose n is like this, 1001 times 1, and the number is divisible by 1001. So we can easily find out that the remainder value of the number like this. We know 1000 equal to -1 plus 1001, and 1000 congruent -1 modulo 1001, and 1000 square gives -1 square, that is 1, and 1000 cube, that is -1 cube, that is -1. So in this way every even power of 1000 will give +1 and odd power of 1000 will give -1. And in this way, if the number can be written in the expression of the 3-digit blocks from the right side and in the form of summation of 1000, various power of 1000 multiplied with 3-digit blocks from the right side, then we can easily compute the sum of its remainder value. And we have seen it that the alternate 3-digit sum from unit digit is the remainder of, because every positive power of 1000 will give every even power of 1000 will give +1, and every odd power of 1000 will give -1, and in this way the alternate digit sum will be its remainder. Now it is very important that the number, since the number is divided by 1001, so its alternative 3-digit sum from unit digit is the remainder. So we can apply this important technique, and we can write the number like this from the right side, taking 3 ones in blue color and next 3 1 in red color. That means every block of 3 ones from right side alternatively blue and red, then next blue blocks of 3 ones, and then red blocks of 3 ones. In this way we can write the number like this. So the number n will look like this, suppose we can put one set of 2 blocks, every blocks containing 2 blocks, every set containing 2 blocks, the blue block and red block having one in one set, taking these two blocks in one set, that is 1, and then set number 2, then set number 3. So if we can just put a serial number of this set, then we can go up to 166 sets of two blocks having 166 into 6 ones. So till now another 5 ones will be remaining, and then it will be 3 blue colored, and then 1 then 2 1 in red, because we can see it every alternate blue and red blocks. So 1001 times 1 will be like this. 1001 times equal to 6 into 166 plus 5 times. So it is very important. The alternate 3-digit sum will be the remainder. So we have to compute the remainder. So now we can compute like this. The first block will take its sign as positive, and then the red color block will take its sign as negative. So we can just write its taking its sign, and in this way all blocks will be written in this way. So up to 166, clearly it is very easy to see that every set of 6 ones, that is 2 blocks, the plus blue 1 1 and negative minus red colored 1 1 1 will form 0. So 166 0. Up to 1 to 166 sets will produce 0 when we compute the sum, and then only the remaining 5 times 1, that is the blue 111 and red 11 will be the existing portion. So when we compute, only we will get the remainder will be the only red colored 1 1 and blue colored 1 1, and 166 into 3 times 1 and 166 into 3 times 1 will be vanish with each other, because equal number of positive 111 and negative 111, so it will give 0, and only the remaining portion will be minus 11 plus 111, that is 100. So for n we will have the remainder 100, and for 7n we will have the remainder 7r, that is 7 into 100 equal to 700, which is the answer. So this is the full solution of the challenging problem, and I think every one of you have got thrill in solving this problem. For more such interesting problem, challenging problem, subscribe the channel and like the channel. Thank you all.